Hey, so let's do some of those tricky percent problems together. Of course, I would love it if you would do these on your own and then just watch the video for the places where you get stuck. But hopefully by the end of the video, you'll be able to do a bunch of these on your own without any help from me. No. Hold on. It's being dumped. Let's make sure that we get it saved. Feel free to fast forward through all of this while it decides that it actually wants to work for us. There we go. Okay. Sarah has 20 Barbies. If 20% of the Barbies are brunettes and 60% of the Barbies are blonde, how many Barbies have a different hair color? So not blonde, not brunette, must have like red hair, right? Okay, so what we do know is there's a total of 20. So 20 will definitely be our whole. We've got to decide what we do for the percent. I think what I'm going to do is I'm going to actually find the percent of the different hair color. And I'm going to do that by knowing that, okay, 20% is brunette and 60% is blonde. What percent does that leave me with? Well, 60 plus 20 is 80. That means I need another 20% to get to 100 total percent, right? So this 20% is the other. That's how I'm going to solve it. I'm going to do that 20 right there. And that will give me two. Two Barbies have hair that's not brown or brunette. Okay, you could have first done that the 80% way, and that would have given you 20, no, that would have given you 18, and then you could subtracted 18 from the total 20 Barbies, and you still would have gotten two Barbies. There were 220 fifth and sixth graders at Lincoln. 60% of the students want to go skiing. How many students do not want to go skiing? So I have to make sure that this 60% is the ones that want to go skiing. So 60% out of the whole total amount of students want to go skiing. That means that it's 40% that do not want to go skiing. So that's what I'm going to do. And I'm not going to simplify because there's already a relationship between 100 and 200. I'm just going to go straight with the times 2, and I'm going to say 80. 80%? No, we already know it's 40% that don't want to go. So that's the number. That's the part of the whole 220 students that do not want to go skiing. There were 300 people who went to Wendy's for a Frosty. 60% of the customers ordered a chocolate Frosty. How many ordered a vanilla frosting? Ha ha ha. So 60% of the customers ordered a chocolate Frosty out of the total 300. Well, again, if 60% ordered chocolate, then what's the other part of 100%? 40% again, huh? That's the same percentage as we had last time. So this percentage ordered a vanilla frosting. So let's times that by 3 and get 120 people ordered a vanilla frosting. Mrs. Frenzel, Mrs. Green, and Mrs. Manson went out to dinner. The price of dinner for all of them was $50. They tipped their server 20% because they're good customers. And the question is, how much did each teacher pay if they shared the price of dinner and the tip equally? Okay, well, I know I'm going to use my green pen because it's Mrs. Green. And do I have the total amount of the price of the dinner? Yeah, their whole entire dinner was $50. So this 20% is just for the tip, right? So I'm going to put a T there to remind me that 20% is for the tip. And I'm going to see that this is a times 5 relationship. 2 times 5 is 10. So I know they tipped the server $10. Their whole entire meal was $50. So altogether with the dinner and the tip, I added, right, because it's a tip, is $60. The question is, how much did each teacher pay if they share the price of the dinner and the tip equally? So I'm going to divide that by 3. Some people, you may be like, okay, well, they shared the dinner equally and they shared the tip equally, and they could do it that way. I'm going to add it all together, then divide it up. So 60 divided by 3 is $20. So the price of their dinner for each of them was $20. An ice cream shop sells 40 flavors. Wow. And 50% of their flavors include chocolate. The rest of the flavors do not include chocolate. How many flavors include chocolate and how many flavors do not include chocolate? Okay, so 40 I know is the total amount of ice creams that they do. 55%, so I'm going to put 55 up here with a C. That 55% is the amount of ice cream that includes chocolate. The rest of the flavors do not include chocolate. So if there's 100% total, 55% include chocolate, then that means that 45% will not include chocolate. Should I do a frowny face? Because any ice cream that doesn't have chocolate in it is not very good. Or just know that's the ones that do not include chocolate. And there's 40 total. Okay, I don't see a ratio way. I might choose to do this the decimal way, or I might choose to simplify and divide both of those by 5. If I did that, that would give me 9 and 20, which would then go into 40. So maybe I'll just do it that way. All right, 18. So 18 flavors do not include chocolate. Austin wants to put a variety of ice cream flavors on display. The display case is large enough to hold 60 flavors. So he has some that have chocolate, he has some that have vanilla base, and he has some that are sherbet based. So what we want to do is we want to complete the table below. So 40% of the ice cream is chocolate, 30% of it is vanilla, 20% is sherbet. So what we need to do is we need to find that actual number. How many is that for chocolate? Well, chocolate is 40% of the total. And do we know the display case is large enough to hold 60 flavors? Okay, so let's do 60 total flavors. And we will see that, 24 of them are chocolate based. Vanilla, 30% are vanilla. There's still a total of 60 flavors. And we're going to, shocker, times this by 6 again to get 18 that are vanilla. And so let's find out how many are sherbet. Will be times 6 times 6, that will be 12. Okay, so that's how many flavors are chocolate and vanilla and sherbet. Awesome. Here's the next question. Has Austin put the maximum number of ice creams in the case? Remember it said that the case held 60 ice cream flavors? Use numbers and words to explain how you know. If he has not put the maximum number in the case, how many more ice cream could he put on display? So actually, let's go back and let's look at this again. There's a few ways we could do it. We could do it the percent, do the percents all equal 100%, or do the number of ice cream flavors all equal 60? Well, I'll do it both ways. You guys can decide which way you want to do it. If I add all of those up, 40 plus 30 is 70, plus 20 is 90. So it looks like he doesn't have all 100% of the display case filled up. If we add these together, 24 and 18 will give me 42 plus another 12 will give me 54. So this also shows that, yeah, he did not put all 60 flavors out. He only filled up 90% of the way. So he has not put the maximum number. He only filled up 90% of the case. For 54 ice creams. How many more ice creams could he put on display? He could put 4 more on display. How did we figure that out? Because 54 is how many is on display. It can hold 60. 60 minus 54 is 6. Oh, erase. He can put 6 more on display, which makes sense because 10% of the 60 is 6. And he had 90% on display, so he needed another 10% on display, which does equal 6. Very cool. All right, true or false? Is it true that 18 is 25% of 72? Well, I'm going to figure out actually what is 25% of 72. And I'm going to do that the decimal way. And maybe I'll do it the ratio way. I don't really like the ratio way. Let's do the decimal way. 5, 36, 4, 13, 0, 0, 1, 8, 1. Yeah! Yeah, it looks like it is. 18 is 25% of 72. True. 30% of 60. 30% of 60 is 18. 75% of 40 is 30. So this one is definitely bigger. 30 is more than 18. Oh, and those are the answers. All right, friends. Hopefully that practice helped. Hopefully you can do them on your own now.